Good morning, dear students, and welcome back to this online class of chemistry. So, in the previous video, we completed the arrangement of electrons in an atom. And now, in this video, I am going to discuss what is valency and the formation of compounds from atoms. So, let's discuss what is the term valency. Valency means the combining capacity of the atoms to form molecules either with same or different elements is known as valency. So what you find? Valency means the combining capacity of the atoms. For example, sodium. The valency of sodium is 1 because it consisting of only one electron in its outermost orbit. So the valency of sodium equal to 1. Like this, see that the compound of hydrogen chloride. Here what happened? That means one atom of hydrogen combined with one atom of chlorine. So the valency of chlorine equal to 1. Okay, that means the combining capacity of the atoms. Okay, and see that next example, that is water. Here what happened? That two atoms of hydrogen combined with one atom of oxygen, okay, to form water. So here that valency of oxygen equal to 2. Okay, and also you can say that valency is the number of electrons donated or accepted by the atoms to achieve the stable electronic configuration of the nearest noble gas. Okay, what you say that about the valency? Valency is the number of electrons. It may be donated or it may be accepted by the atom to achieve the stable electronic configuration of the nearest noble gas. Okay, so let's see. As we know that metal means what? That means it contains 1, 2 or 3 electrons in its outermost orbit, and they can easily lose the electrons and form that cations. So let's see that example. Okay, that sodium has one electron in its outermost orbit. Okay, that means what? It will be lose the one electron to achieve the stable electronic configuration of the nearest noble gas, that is what? Neon. Okay, and when they will be lose the electron, they form cation. So see here that example, sodium, that atomic number equal to 11. Okay, so the electronic configuration equal to 2, 8 and 1. So to achieve that stable electronic configuration, what happen? It lose one electron and form sodium ion, that is cation. Okay, like this, see another example, that is magnesium, whose atomic number equal to 12. Okay, and the electronic configuration 282. So to achieve that stable electronic configuration, he lose 2 electrons and form magnesium ion. Okay, and what is that after formation of magnesium ion, the electronic configuration equal to 2, 8. That means in the outermost orbit what? 8 electrons are there. That means it achieved that stable electronic configuration of nearest noble gas, that equal to neon. Okay, like this another example you see here, aluminium. In aluminium, atomic number equal to 13. So in the outermost shell, it contains 3 electrons. So to achieve the stable electronic configuration, it loses 3 electrons and form aluminium ion. Okay, and what is that electronic configuration of aluminium ion? That is 2 and 8. That means in the outermost shell, it contains 8 electrons. Okay, so what you find here? That means metals are lose the electron to achieve that stable electronic configuration, okay, of that nearest noble gas. Like these metals, that non-metals, they accept the electron to achieve that stable electronic configuration. Clear? For example, see here on example here, chlorine. Chlorine atomic number equal to 17. So its electronic configuration 2, 8 and 7. So to achieve that stable electronic configuration, it requires one more electron. So it will be gain one electron and form chloride ion. That is what? Anion. Okay. So this anion, when it will be after formation of ion, that is chloride ion, the electronic configuration equal to 288. That means 8 electrons are in that outermost orbit. Like this, another example, see here, oxygen. Oxygen atomic number equal to 8. So the electronic configuration 2 and 6. So in the outermost cells 6 electrons are there. To achieve the stable electronic configuration, it requires 2 more electrons. So after gain of 2 electrons, it formed that what? Oxide ion. And the electronic configuration of oxide ion, see here, that equal to 2, 8. That means what? In the outermost orbit, it have what? 8 electrons. That means it achieved that stable electronic configuration. Next example, see here, nitrogen. Okay, nitrogen, you know that atomic number of nitrogen equal to 7. So the electronic configuration you see here 2, 5. So to achieve the stable electronic configuration of that nearest noble gas, okay, it required 3 more electrons. And he gained that 3 electrons and formed that what? Nitride ion. Okay. And after formation of nitride ion, the electronic configuration see here, that is 2, 8, which is the nearest noble gas, neon. So what we observe here, that means metals are lose electron to achieve the stable electronic configuration, and non-metals are accept the electron to achieve that stable electronic configuration. So here one more question found, that what is stable electronic configuration? Stable electronic configuration means in the outermost orbit it must be contain 2 electrons or 8 electrons. All that inert gases or the noble gases have stable electronic configuration. So let's see that example. In the outermost orbit or the Valency cell. Valency cell means what? The outermost orbit. Okay. That means see here stable electronic configuration. First example, see here helium. Helium atomic number equal to 2. That means in the outermost orbit or in the Valency cell it contains 2 electrons and forms that what? Duplet. So it is known as what? Stable electronic configuration. Then the next example, that is neon. Neon atomic number equal to 10. So the electronic configuration 2, 8. That means in the Valency cell it contains 8 electrons and form octet. This is known as what? Stable electronic configuration. That means in the outermost cell it must be contain 2 electrons or 8 electrons. And the next example see here, that is argon. Argon atomic number is 18. So the electronic configuration 288. So in the Valency cell it contains 8 electrons and form octet. This is known as what? Stable electronic configuration. Next we have discussed that what is unstable electronic configuration. That means in the Valency cell must be incomplete. That means it not contain the 2 electrons or 8 electrons in their outermost cells. Let's see that example. See here that metal, sodium. Sodium atomic number you know that 11. So the electronic configuration 281. That means in the Valency cell it contains 1 electrons. That is incomplete. So to be achieve the stable electron, it must be lose the electron and form that sodium ion, that is cation. Okay. Like this chlorine, see, chlorine atomic number 17. Whose electronic configuration 2, 8 and 7. Okay, that means it requires 1 more electron to achieve that stable electronic configuration. So in the outermost cell what? 7 electrons are there, that is incomplete. So this is known as what? Unstable electronic configuration. So what we observe here? That means the atoms which contain, the Valency cell contains 2 electrons or 8 electrons. They are known as stable electronic configuration. And the Valency cell, if does not contain 2 electrons or 8 electrons, then it is known as unstable electronic configuration. Okay. Then next we move to our next topic, that is formation of a compound. How the from an atom, that means how the compound will be formed. Okay. See here, when the 2 atoms combine together, okay, then it is form a compound. See here, that is electrovalency, or that you can say that electrovalent compound. Here you can say that sodium and chlorine. Sodium has atomic number 11. Okay, that means 2 atoms are there. Now, sodium atomic number 11, that electronic configuration is 2, 8 and 1. And chlorine, that atomic number 17, that electronic configuration 2, 8 and 7. So, sodium lose one electron to be octet and chlorine require one more electron to be octets. That means sodium gives the electron to chlorine. That means the electron is transferred. Okay. So the bond is formed in between the sodium and chlorine by transfer of the electrons. So the bond formed by transfer of electrons is known as what? Electrovalent bond, or you can say that electrovalency bond. This is also known as ionic bond. Okay, see here sodium chloride, that sodium lose one electron and form Na plus ion, and chlorine gain one electron from chloride Cl minus ion, and the bond is formed in between the sodium and chlorine. Okay, that is known as what? Ionic bond. That means ionic bond means what? The bond is formed by transfer of electrons is known as a ionic bond, or you can say that electrovalency bond. Like this, see another example, oxygen molecule. You know that how the oxygen molecule is formed? By sharing of electrons. That means by when two oxygen atoms combine together, they form that oxygen molecule. So see here, oxygen. That means two atoms of oxygen combine with each other. So atomic number of oxygen is 8. Okay. So the two atoms, see here, the electronic configuration 2 and 6. That means both the oxygen require two more electrons to be octet. Okay. So that means they will be share with each other. Okay, see here from the figure you can find out both of the oxygen atom share with each other and form that oxygen molecule. And this type of bond is known as what? Covalency bond, or you can say covalent bond. So covalent bond means the sharing of electrons. That means the bond formed by sharing of electrons is known as a covalent bond. So by this the bond is formed from an atom. Okay, that means the bond formed by the transfer of electrons is known as ionic bond or electrovalency bond, and the bond is formed by sharing of electron is known as a covalent bond or covalency bond. So with this chapter is completed. Thank you.